right, good morning. I found out this morning, well, actually last night, I guess we got an email. It is read day in math on Wednesday. So that pushes our test to the 5th instead of the 4th. So it's just I just moved everything over on the calendar one day. And the very last lesson that I was going to teach before semester test review, I just took it out. So anyway, so test will be on the 5th. Read day Wednesday. Wednesday read day. We're going to continue with circles. Quick reminder, if you have a central angle, it's always the same as the arc. So like if this was 100 degrees, the arc is also 100 degrees. So that's only if the angle goes to the center. We're going to talk about inscribed angles today. So an inscribed angle does not stop at the center. It goes all the way to the other end. So this inscribed angle, I could name that angle ACB. And then the intercepted arc is arc AB. That's the arc that angle is going to. So the inscribed angle, I guess you're going to have some problems where you have to name the inscribed angle and the intercepted arc. So how could I name this angle right here?
C.
I could name an angle C.
ACB.
I think you're going to have to name it in 3 letters on your assignment. So ACB or
BCA.
BCA. What arc does it go with?
AB.
AB. Does everybody say it goes with that arc? Or BA? Okay, how could I name this angle?
NPM.
MPN or NPM. What arc does it go with?
MR or N.
MN, yeah. Or NN. That's hard with the M's and the N's. Yeah. Okay, so you're going to have the first 3 problems like that, where you have to name the inscribed angle and the intercepted arc. All right, so the inscribed angle is always half of the arc. So remember, if it stops at the center, it's equal. If this angle goes all the way to the other end, it's just half. So if this arc is 100 degrees, this angle would be 50 degrees. So it's just half. Instead of the same, it's half. So let's look at a couple of examples. So if this arc is 110 degrees, what would the inscribed angle be? 55. Does that make sense? So it's just half. So this one I have several. So you kind of have to look and see which angle goes with which arc. So like, do you see how X goes with the 90 degrees? So what's half of 90? 45. So Z goes with 170 degrees. What's half of 170? 85. And then there's a couple ways to get Y. What do all the angles in a triangle add up to? 180. So you could do 180 minus 45 and 85. Or what's the degrees all the way around a circle?
180 or 360.
360. So you could do 360 minus 90 and 170 to get that arc. And then just take that arc and divide by 2. That sounds like more work though. What's 180 minus 85 and 45? What is it?
50.
50? Thank you. Okay. So that just means this would have been 100. Okay, so on this one, I do need to find this arc, so I can then just divide it by 2 and get that angle. So what's the degrees all the way around a circle?
360.
So 360 minus 60, I know is 300. What's 300 minus 82? You guys have a calculator. What is it?
218.
218. So this arc's 218. What's half of 218? 109. So you guys see how the inscribed angles work. Okay. So there is a few theorems to go with that. If you have 2 inscribed angles that intercept the same arc, they're going to just equal each other. So like, let's say this arc is 100 degrees. Do you see this inscribed angle right here that goes with that arc?
Mm-hmm.
Half of that, so this would be 50 degrees. But this inscribed angle also goes with that same arc. So since they go with the same arc, these 2 inscribed angles have to equal each other. So if two inscribed angles intercept the same arc, they equal each other. Another theorem just says if you have an inscribed angle intercepting a semicircle, it has to be a right angle. Well, what is a semicircle? What's
180 degrees.
180, so what's half of 180?
90.
90. So that's why if you have an inscribed angle that intercepts a semicircle, it's a right angle. Okay, one more thing. If you have a quadrilateral, it's a four-sided figure, inside a circle, opposite angles are always supplementary. That just means they add to 180. So like if this angle was 120, this angle would have to be 60. Does that make sense? So only in quadrilaterals in a circle, the opposite angles add to 180. So let's look at a couple of examples that deal with that. First of all, let's look at this one. Do you guys see that angle C is inscribed in a semicircle?
That's crazy.
So this would be 180. What would angle C have to be? 90. I can find angle B because it goes with the 95. What's half of 95? That would be a decimal.
47.5.
47.5. Okay, and then I still need to find arc A. Well, do you guys see that this is a semicircle? What's 180 minus 95?
85.
85, okay. So some of them are kind of hard. We learned if you have a quadrilateral inscribed in a circle that opposite angles add to 180. So do you see the 68 and angle A?
Mm-hmm.
Those have to add to 180. So tell me what 180.
112.
112, thank you. So A would be 112. Let's look. This is kind of a tricky problem. You guys see the 71 degrees right here? So it goes with this entire arc. What's 71 times 2? 142. So that means this entire arc would be 142. If this is 104, what's 142 minus 104? And then I'd get C. Okay, good. Was that hard?
No.
Was that kind of hard? No? Okay, how can I get, to get B, I can look at that 112. So I've got this inscribed angle that goes with this entire arc. So 112 times 2 would be 224. So 224 minus 104, what's that? 120? Okay. That's kind of hard. Some of it I think is hard. And then if you have two inscribed angles that intercept the same arc, they equal each other. So angle X goes with the 72 and angle Y goes with the 72. So these two angles are going to equal each other. What is half of 72? 36. Thank you. Okay. All right. One more concept that's kind of the same thing though. If an inscribed angle happens to go outside your circle, it's still always half of whatever the arc is. So even if it goes outside the circle, that angle will still be half of whatever the arc is. So sometimes inscribed angles stay inside the circle, sometimes they go outside the circle. So like if I look at this one, do you guys see that that's 220? What's the degrees all the way around the circle?
360.
So 360 minus 220?
140.
What's half of 140?
70.
70. So X would be 70. So it's still half of whatever that arc is. Look at this. Do you see that 115 degrees?
Yeah.
What do these two angles have to add up to?
180.
180. So what's 180 minus 115?
That's not it.
65? And then to get the arc, take the 65 times 2. What's that, 130? And then one more example. Remember, the central angle and the arc are always equal. So if it just goes to the center, that 44 degrees would be this arc. Oops, 44. But if it goes all the way to the other end, it's half. So angle A would be half of 44, which would be 22. All right. Somebody help me with their calculator. What's 360 minus 160 minus 44?
136.
136?
156.
156, thank
Definitely
you. So this would be 156. How would I get angle B? Divide by 2. So what's 156 divided by 2? 78? Thanks. Okay. All right. So I got a couple jokes. I think your assignment's unlocked, isn't it?
Yeah.
Okay. I tried to make it earlier this time. So this is a Calvin and Hobbes. So Calvin's mom is like, bath time, and he hates baths. So she's like, come on, let's just get it over with this time. She's looking around the whole house for him, and he's hiding in the bathtub because he's like, she'll never look here. Did you guys have little brothers or boys? Did you hate taking baths when you were younger? And then this is just kind of weird. Cyanide and Happiness. Have you ever seen those comics? They're kind of weird. It's like, whoa, I've never seen a real mermaid before. I'm not a mermaid. My legs were stolen from me. What do you mean? There's a fish running around the lake. That's just weird. Just weird. Okay. So on your assignment, I thought this was kind of funny too. The egg's at a chiropractor. You might hear a crack. Okay, so starting with question 1, tell me, is it an inscribed angle?
Yeah.
If it is, you have to name the angle, and then you have to name the arc. So yes, this is an inscribed angle. It goes all the way to the other end. So just put YES, lowercase.
Wait, if it doesn't go all the way to the other
Then it
end?
is not, and you'll say no. So how can I name this angle right here? BAC or CAB. Put capitals when you name the angle.
What's a regular one where it goes to the what's called again?
Central angle. When it goes to the center, central angle. What's the intercepted arc? BC. Okay. So if it does not go all the way to the other end, then that would not be an inscribed angle. You would say no. If it just goes to the center, it is called a central angle. Do you know how to spell that?
CENTRIL.
Central angle. So this would be no, it is not an inscribed angle. So an inscribed angle has to go all the way to the other end.
Number 7.
Okay, hang on. Okay, so some of them, just remember the inscribed angle is half of the arc. I have one like number 7, it says be careful on this. So for number 7, I'm not looking for arc WY, I'm looking for arc WX. But I can find arc WY, what's 57 times 2?
114.
114. But that's not my answer. I want WX. Do you see how this is a semicircle? How could I find WX?
Okay.
Yes, 180 minus 114. 180 minus 114. What is that? 66? I should have pulled up my calculator app. Okay, so that's one to be careful on. I think I have another one like that too. Number 11. So I put be careful because it's looking for GH, not HJ. Let's see. Look at question 14 real quick. So I have 2 inscribed angles that intercept the same arc. So I have this angle that intercepts JK, and then I have this angle that also intercepts JK. So two inscribed angles that intercept the same arc equal each other. So you'll just put them equal. X equals 2x minus 54. So put them equal to each other if they intercept the same arc. And then you have to solve. And then don't forget, so same with 15, equal to each other. And 16. Oh, look at 17 really quick. Do you guys see how angle Q is inscribed in a semicircle? So what would angle Q have to be? 90. Good. So this is 90 degrees. So then to find P and R, that does not mean they're each 45 degrees. I don't know that this side equals this side. But I do know what all the angles in a triangle add up to. What do they add up to? 180. What is 180 minus 90? So these two angles would have to add to 90. So if I combine like terms, 3x and 7x is 10x. Positive 1 and negative 1 cancel out, so that would equal 90. And then you can solve for x and plug it in to find angle R.
X equals 9.
X would equal 9, and then you have to plug it into angle R, so 7 times 9 minus 1.
63 minus 1 is 60.
So 18 will be the same, 19 will be the same. Number 20, your last problem. Remember that opposite angles in a quadrilateral are supplementary. They add to 180. So angles H and K, 2x plus 21 would equal 180. The opposite angles add to 180. And then same with J and G. 3y plus 9 plus 4y minus 11 would equal 180. So you'll have to combine like terms.